Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to start our studies on hypothesis testing for population mean. So in our previous video, we learned quite a lot on how to understand hypothesis testing, how to calculate your critical value from your Z table and the rest. So if you haven't watched the videos on that, it will be of your benefit to go and watch that video before you start learning the hypothesis testing for the population mean. The procedure for the hypothesis testing involves a single population mean are presented as follows. Since we are comparing mean for one sample, the hypothesis testing will be that, right? So we have to learn how we can set our hypothesis for the population mean. The reason why we are seeing the mu here is that we are setting hypothesis test for the population mean, and here the population mean is represented by mu. So here we have what we call the two-tailed test. The two-tailed test. So how can one set a hypothesis testing for the two-tailed test? So here to be H0 where our mu is equal to mu naught, and H1 where our mu is not equal to mu naught. We can only see that this is a two-tailed test since our H1 is carries not equal to sign. So this is what a two-tailed test. So what about the one-tailed test, but it is still to the right? When it is still to the right, this is how the hypothesis can be set. We having our H0, which is our mu is not equal to mu naught, and our mu is greater than our mu naught. This is just representing that this is what a right-tailed test, right? A right-tailed test. So here our mu will be greater than our mu naught for the alternative hypothesis, and our H1 here, H0 here, will be having for the left. H0 will be having mu is equal to mu naught, and mu1. Sorry. Our H0 here will be mu is equal to mu naught, and our H1 here will be mu less than what mu naught. So this is just resembling it is left tail test, right? Since our H1 is carrying a less than sign, or at alpha of what? Or at alpha level, a given alpha level given. So before we can solve a hypothesis testing for a population mean, we have two things that we have to look at. We have what we call the Z test for the mean, and then T test for the mean. We use the Z test for the mean when our population standard deviation is known and our n is greater than or equal to 30. We use this to construct the confidence intervals for the population mean. So that's the same idea that we are going to use to construct the hypothesis testing for the population mean. So here we are saying that the Z test is a statistical test for the mean of a population. It can be used either when our n is greater than or equal to 30, or when our population is normally distributed and our population standard deviation is known. So once our population standard deviation is known and our n is greater than or equal to 30, we are going to use what we call the Z test, right? So how can one use the Z test to calculate for our hypothesis testing, right? We have what we call the Z curve. The Z curve is also called the Z statistics. And the Z statistics here is given as this. I'm coming. Is given as our x bar minus mu divided by sigma divided by square root of n, where our x bar is given as the sample mean, our mu is given as the hypothesized population mean, and our sigma is given as population standard deviation, and our n is called the sample size. So once you have been able to calculate for our Z calculated and also calculate for our Z subscript alpha or Z subscript alpha divided by 2, we are going to compare our Z critical, that's the critical value that we will get for this one, and the Z calculated to make our conclusion. So this is how the conclusion is being drawn. We are saying that if our if our Z critical, right, that's the Z critical contains Z subscript alpha and Z subscript alpha divided by 2. We are saying that if our Z curve is greater than our Z calculated, we are going to fail to reject H0, right? But if our Z curve, if our Z critical is less than our Z calculated, that is Z curve, we are going to reject H0, right? So this is how you are going to make the conclusion. But we have one assumption that I want us to go through. So the first assumption is assumption for the z-test for when our population standard deviation is known. So we are having the sample is a randomly sample. So the sample that we are going to use to calculate for this z-test is must randomly selected, and then either our n is greater than 30 or the population is normally distributed, or our n is less than 30. So what I want you to know is that when our population standard deviation is known, no matter whether if our n is less than or equal to less than 30 or greater than or equal to 10, we are still going to use our z-test to calculate for that, right? So let's go to some examples for us to really appreciate whatever we have discussed here today. So let's go to the example. So this is our first example. So our first example says the Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for a stroke victims is 24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and find out the average cost of their rehabilitation is 26,343. The standard deviation of the population is $3,251 at an alpha of 0.01. Can it be concluded that the average cost of the stroke rehabilitation at a particular hospital is different from 24,672? So here we have to get our parameters down. We know that we know from here that our average cost for the rehabilitation for this victim is 24,000, right? 672. So we know that our mean, right? This one will be for the population, right? So our population mean will be 24,672, right? And the average cost, right? And then he said, to see if the average cost of the rehabilitation is different at a particular hospital, a researcher selects a random sample. So you see the random sample was selected and our n was given as 35. And with that random sample, they use that random sample to calculate for our sample mean. And then we learned that our sample mean, our x bar from the question was given as 26,343. So this is what we have. Right now we have our sample mean, we have our population mean, and our n. Right, left with our standard deviation, population standard deviation, and our population standard deviation from the question 2 was given as 3,251, right, as our population standard deviation. Right now we know that our n is greater than 30 and our population standard deviation is given. So we are going to use our z, where our z statistics was given as x bar minus mean divided by sigma divided by square root of n. So this is what we are going to have. So right now we have all the parameters. So all that we have to do is to just substitute the parameters inside the formula and the work is done. We know that our x bar is given as 26,343 and our mean is given as 24,672. That's what we have. So here we are going to subtract this one from this one as we have here, and our population standard deviation was given as 3,251 and our n is given as what? 35. So this is what we have here. So if you do your addition and multiplication very well, we are going to get 3.04, right? And our alpha was given to us. Our alpha was given to us as 0.01. But first, we have to set our hypothesis, right? Yes. So we learned that he said we should conclude that the average cost of the stroke rehabilitation at a particular hospital is different from 24,672, right? So here he just tell us that this average is, right? The moment you hear is, it means that our mean is equal to that particular mean. Our mean is equal to that particular average, right? And that average there was 24,000. So here we are going to get our h naught to be mu to be equal to we are going to get our h naught to be mu be our mu to be equal to 24,672, right? And then our h1 to be equal to mu is not equal to 24,672, right? So this is what we are going to have, right, for our mu, right? So right now we have our z to be 3.04, and then we have our z subscript alpha to be 2.58, right? Yes, it's 2.5 since it's a two-tailed test. It's a two-tailed test because our alternative hypothesis carries not equal to sign. So we have to divide our alpha by 2, right? And for this one, I've taught you how to solve it. So here will be z subscript alpha divided by 2, which will give us, so here we are calculating for our z calculated, sorry, our z critical. So here we are going to get our z subscript 0.01 divided by 2, since it's a two-tailed test. So when you divide it by 2, you are going to get z subscript 0.005, right? So you are going to locate 0.005 from our table, right? So here, since it is in the negative table, in the negative table, we are going to, since it is in the negative table, we are going to subtract 1 from it. So when you subtract 1 from it, you are going to get 0.995. We are going to get 0.995. So this will be our probability, and go straight to the z table. Just locate where we will find 0.995, trace it to the column and then the row to get your critical value. So here our z score is giving us 2.58. That's our critical value, right? So right now we have our z, we have our critical value to be 2.58, and we have our z calculated to be 3.04, right? So it's a two-tailed test, right? So here we are going to get 2.58 for our 2.58 for the critical value, right? To the positive side, right? To the negative side, I'm coming. To the negative side, we are going to have what we call negative 2.58, right? Since this is the positive side, so when we negate this one, I'm going to get the negative side, so negative 2.58. And then once you draw this diagram, we are going to see where our 3.04 lies. You could see that 3.04 is greater than our critical value, so it will definitely lies in the rejection region, right? So here, since our z subscript alpha divided by 2 is equal to 2.58, is less than our z calculated, which is equal to 3.04, we are going to reject our h naught, right? We are surely going to reject our h naught. So this is how we can solve for this question. Let's go to our next question. So our next question here says that a researcher believes that the mean age of a medical doctor in a large hospital system is older than the average age of doctor in the United States, which is 46. Assume the population standard deviation is 4.2 years. A random sample of 30 doctors from the system is selected. And the average age of the sample is 48.6. Test the claim at an alpha of 0.05. So this is the question, right? This is the question, and then we could see clearly that the question was saying that a researcher believes that the mean age of the medical doctor in a large hospital is older than the average age of the doctor in the United States, and which is 46. So here our alternative hypothesis is given, and the older means that it is greater than. So here our h1, right? Our h1, right? That's the alternative hypothesis will be u naught is greater than 46, and our h naught will be u is greater than 40. U is equal to 46 at an alpha of 0.05, right? So this is just this is a right-tailed test. This is a right-tailed test, and then from the question we can deduce our population standard deviation. Population mean is 46. Our sample mean is giving us 48.6. Our population standard deviation is giving us 4.2, and our n was giving us 30. And this is our z. We said our z is equal to x bar minus mu divided by sigma divided by square root of n, where we are going to have 48.6 minus 46. divided by 4.2 divided 4.2 divided by n. And we know that our n, we know that our n, you know that our n is given as 30. Our n is given as 30. So once you point this on your calculator, you're going to get 3.33, right? And then also solve for your z. And this one is a one-tailed test, right? Since our alternative hypothesis was having a greater than sign, so it's a one-tailed test, and it is still to the right. Since it's still to the right, we're going to have z subscript alpha z subscript alpha, and then this one is in the negative table, so you subtract 0.05 from 1 to be in the positive table, which will be z subscript 0.95. And then when you locate the probability 0.95, we are going to get our z critical to be 1.65, and here is 1.65, and we could see that 1.65 is less than 3.33. That's our z calculated, and we could surely conclude that since our z subscript 0.95 is less than z calculated, we reject what? Our h naught. So this is how this question will be solved. So in our next video, I want to use the t-test to calculate for our hypothesis test. So kindly stay tuned on this channel, and then make sure you subscribe and share so that this video will get viral for people to also watch. Thank you for watching. Bye.